Now we're going to do the vsepr structure of H2CS. Okay? And just because it says vsepr, don't freak out about it. It still follows that same pattern. We still need the Lewis dot structure. Who's going to be in the center? Hydrogen can make one bond. Carbon can make 4 bonds. Sulfur can make 2 bonds. So carbon is going to be in our center. And I'm just going to spread the other guys around. Doesn't matter where you spread them around. Remember, it could be SHH. Or HHS, whatever you want to do, as long as these guys are outside and carbon is in the center. Okay, if you see, I already drew them with the single bonds because I know every single time they have to at least single bond to the central atom, to the hub, so that they form a molecule. Okay, and now I need to make sure that I have all my valence electrons. Carbon has how many? 4. So 1, 2, 3, 4. These guys, remember, you can picture them like dumbbells. Okay. So carbon has 4. 1, 2, 3, 4. Okay. Hydrogen has 1. Hydrogen has 1. Sulfur has 6. So I need to change that. 1, 2, 3, 4, 5, 6. Okay. So now I've checked and my valences are correct. Again, you can still go and do that process that we did before. I'm just speeding it up a little bit because we're getting to that next layer. Okay, hydrogen is happy. He has 2. This hydrogen's happy. He has 2. This sulfur is not happy. He has 1, 2, 3, 4, 5, 6, 7. That's incomplete. Sulfur wants to have 8. Carbon here, 1, 2, 3, 4, 5, 6, 7. He is not happy. So I need to up that level of bond. It doesn't mean I'm going to draw a double bond here with hydrogen. Hydrogen's already done. Sulfur and carbon aren't happy. So I need to add another bond there. So now I have a double bond. And now what happens? Carbon is 1, 2, 3, 4, 5, 6, 7, 8. Carbon's happy. How about sulfur? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I've met my octet rule. So it's going to be C with a single bond H, C with a single bond H, and C with a double bond to S. And now when I go look at my vsepr structure, remember I have to count the number of atoms off the center. So I'm not counting carbon. Besides carbon, I have 1, 2, 3. So I have 3 off the center. And lone pairs means any unbonded electrons just around carbon. Well, carbon doesn't have any, so 0 lone pairs. Okay, so now when I look here, a 3, 0 is going to look like that, trigonal planar at 120 degrees. Trigonal planar at 120 degrees. And if you notice, that shape is symmetric. Okay, so he's symmetric. Now I have to check the other things. Any lone pairs around carbon? Nope. Symmetric? Yep. What was my other thing I had to check? Oh, different atoms. I do have different atoms, which means this guy is polar.